Hello, my name is Philip, and in today's video we will show how a charge moves in a magnetic field and what forces, or to be more clear, what force acts on this proton and how it moves. And at the end of the video, we will show some examples where this might be useful. So firstly, we will show how we will represent our magnetic field so you're not confused. So the first one with the cross, that will be our magnetic field that points into the screen, right? So you see only the bottom of the arrow. However, the second one with the dot, you see only just a tip of the arrow, so it points outside of the screen. So what do I mean by that? Well, imagine that you're looking at your screen, right? And if the magnetic field will point into the screen, we'll get this X symbol. And if the magnetic field will point in the opposite direction, we'll see just the tip of the arrow. So there will be only the circle with a dot. And hopefully you're not confused with this, because it will be pretty important later in the video. So if you're confused, just pause the video and just imagine it yourself, and hopefully we can move on now. Okay, so let's now have a magnetic field that points into the screen, and let's also have a charge, in this case proton, that travels with some velocity to the right. What we now want to find is the force, or some force that will act on the proton with the magnetic field. The magnetic field will not generate, but there will be some force that will move the proton. And to calculate this force, we will use this magical equation where the Q is the charge of a proton, and then we have this V and B, and between them you see this X sign. The V is our velocity, the B is the strength of the magnetic field, and this X sign means what's called cross product. And this cross product, the result of this cross product, will give us the direction of the force, the final force, right? The proton could go anywhere. It could go like to the middle, or into the screen, or outside the screen. We want just one direction, and this cross product will give us, and we will show how it's done. So to calculate this cross product, only its magnitude, only we will get the number from this, and it's just a simple multiplication, except at the end there is a sign of the angle that the velocity vector and the magnetic field makes. In this case, it's 90 degrees, right? They are perpendicular to each other. So the sign of 90 degrees is 1, so we can just forget it. But if it would be some different angle, sorry, we would have to put it in the calculator, and we'll get some number that will multiply with the rest of the terms in the equation. So when we calculate all this, we make this cross product, and we multiply with the charge, we'll get only the magnitude of the force. And now here comes the little bit tricky part, where we will use what's called the right hand rule to determine where the force, or where the direction of the force will be. Yeah, right. You can see that the direction could be anywhere, but we want just the one arrow. Okay, so let's have our magnetic field and our proton, and now we will use our right hand to find the direction of the force. So we take our right hand and we take the equation, and now the thumb, or direction where the thumb will be pointing, will be our force, or the final product of the cross product. Then our index finger will be the velocity vector, and the magnetic field will be our middle finger. So take your right hand, point your index finger in the direction of our velocity, then point your middle finger inside, right? The magnetic field goes inside the screen, so into the screen. So point your middle finger into the screen, and if we got it right, our thumb should be pointing upwards. So the force will be upwards, and now the proton will go upwards. But where will the force will be now, right? Because now the proton goes upwards, so the velocity or the velocity vector is upwards, but the force has to be always perpendicular to the velocity vector. So now it will look like this, but that's not the direction of the force that we got from the right hand, right? Well, it turns out as long as the proton or the charge is in the magnetic field, it will go in a circle because the force will always point to some imaginary middle of the circle, and we can actually calculate the radius of the circle, and that's exactly what we'll do in the example in a few seconds. Okay, so let's have some numbers. We have the magnetic field in Teslas, then we have the velocity in meters per second, and then we have the charge in coulombs, and the number you see there is a charge of a proton, which is a constant, and it's exactly the same as a charge of an electron, but only it's positive, and the charge of the electron is negative. And we want what we want to get to find is the radius of the charge or proton that will make in the magnetic field. And for that, we will also need the magnitude of the force and the direction of the force. So we can start with the direction, right? So take our right hand, index finger with the velocity vector. So now points our index finger points to the right. Middle finger with the magnetic field, so it now points out of the screen, right? And if we get it right, our thumb should be pointing downwards, and that will be our direction of the force. So we have the direction. Now we can calculate the magnitude. For that, we can use the equation from before. So we just put in the numbers, and we get this 7.85 times 10 to the negative 12 newtons. So that's our magnitude. And now for the radius, we will use the equation for the centrifugal force. Well, what is centrifugal force? Well, imagine you have some ball attached to a rope, and you spin that ball around your head. Well, the ball acts on the rope with some force, right? And that's exactly the same or the same, I don't know, example as we have here. We have some force that acts on the proton, and that's the force that we calculated now. That's the 7.8 times 10 to the negative 12 newtons. And so we have the force, we have the mass, the m there is the mass of the proton, which is also a constant, so we can just find it on the internet. We have the velocity, and what we want to find is the radius. So we just get the radius from the equation, and now we have all the elements in the equation, so we can just put it in, and we get the 1.044 meters, which is actually quite a neat number, right? You can imagine 1 meter, hopefully, and that's our radius that the proton will make in the magnetic field. And now, will the proton goes clockwise or anti-clockwise? Well, we have the velocity pointing to the right, and the force is going downwards. So hopefully the logic says us that the proton will go in clockwise direction, right? And that's the answer. Well, now you can ask yourself where this is used, or why this is useful. Well, despite it's mind-blowing, or at least when I first learned about this stuff, I was mind blown, right? How for example, how the magnetic field knows how fast the proton is going. I didn't know that, and I don't think I know that now. But yeah, it's like the physics behind it is just I still really don't understand it. But now the question, where this is used? Well, if you remember those monitors or those TVs, well, the big boxes, right, the CRT monitors, well, they had this electron gun there that shoot or shoots there are some of them, so that shoots the electron gun shoots the electrons to the screen, and the magnetic field or the right amount of the magnetic field can change the direction of this electron, right? So it can change the intensity, the colors on the screen, and it shoots many electrons there, and the magnetic field just changes their directions, and it makes the image on the back of the screen. And it's also used in CERN collider, Hydro Collider, I think it's called, in Geneva. And why do you think it's or the collider is in a circle? Well, they make these protons and these particles spin really fast, really fast, and they crash them together in the you see the collision there. You have the LHC collider and the big collider. And why do you think that they are both in the circle? Well, the charge in the magnetic field spins in a circle, right? So they have this big magnets there, and they generate the enormous magnetic field that spins the particles or the charged particles around, and they smash them together. And what they get is they get this picture. And again, there are some circles, and all these little circles are particles that pop out into the light for a split second. And based on these pictures, they can calculate the particles mass. I don't know what else. The bunch of stuff they can get from these pictures, and they can like discover new particles and make some definitions about them, and it's super useful, right? That they're discovering new particles only based on these pictures, or this is actually how they or I think is how they discovered the new Higgs boson. If you follow the new physics, and again you can see the small particles that are making or starting to make the circles, and with the equations that we have just shown, they can calculate a bunch of stuff about these particles, and they can find the new particles. So hopefully you enjoyed this little video that showed you only the basics of the more complex and advanced technologies like an electric motor or I don't know, the Faraday's law, how the from we can make electricity from the movement, right? The water electricity, and how the turbines actually make the electricity, and all this and more we will show in the next video. So hopefully you will look forward to them, and I will see you in the next one.